Namaste. Now we are going to write our Verilog code and online simulator. But there are some limitations, but that's okay, it's manageable. But here we not require any softwares or anything. Just in your mobile also you can code and you can simulate any Verilog code and you can see the output. So for that, what we have to do means just go to the Google Chrome and type EDA Playground. That's one of the website we are using in order to simulate the Verilog code. So EDA Playground. And yeah, you are going to see the edaplayground.com website. Just open that. So in that, you just have to create one account. Because whenever we write any code, that we just have to save, because we want that some other times we can retrieve that. So without creating the account also we can simulate, but that code will not going to remain. So what we have to do means just go to the login section. Then there we need to first sign up. So you can directly log in with one of those, like login through Google or Facebook, or if we want the full access, then you can just use your college mail ID or any corporational mail IDs. So now I'm just going to log in through the Google. I don't have any mail IDs like that, so just Google, and here just type your Gmail and password. Okay, then yeah, it will going to create our account. Okay, now here you can see the profile. Instead of login, we can see the profile, so that we come to now that we successfully created our account. So now when we come to this window, there are basically two major windows in the Verilog. Okay, so and here's some selections, and here's some note writing windows. That means what we did, like that, something note for that program. Okay, so here Testbench or design. Here there are lots of options are there, like VHDL, Python, C++, like that. So here what we have to do means we just have to use now we are going to write the Verilog program. So just click on System, Verilog or Verilog, like this, the first one that you just have to select. And next option, Tools and Simulator, because we need some simulator for simulating these such codes and to generate the graph. So for that, just go to the Tools and Simulator section, and here for easy purpose we will choose this Aldec Rivera Pro, this one. Okay, just choose this, and yeah, runtime, that means how much time our code has to run. When we see it's when we just think of its output graph, the graph is like time versus anything, like based upon the time. So here we just have to give the time in yeah, millisecond. So what we just do means we just type 50 millisecond. Okay, it depends upon your code how much test cases are there, like that. We will come to understand that. And we want open EP wave after run. EP wave means it is a one tab, like it's just one Chrome tab. There we can see the output graph. So we need to see the output of our code. So we just check on this. That means click on this open EM after run. That's it. Now the major part is writing the program. That we already saw for some basic gates and I think the AND gate. So now what we do means we are going to write the Verilog code for half adder. That's also the easy one. So for that, first of all, here in the window there are two parts. One is for the test bench and another one is for our top module. So here you can see that design.sv and here testbench.sv something, but the actual name is it is .v, Verilog. But here there is something name is design.sv, like that. So here we have to write whatever the design part that we are going to design, and in this part we have to write the test bench. So we are going to write the half adder. Okay, we just comment it, and half adder. Okay, so half adder means we have the two inputs, that is the A and the B, and it will going to make the sum of A and B. The half adder circuit will going to make the sum of A and B, and it will going to produce the sum and the carry. Okay. Before going to write any Verilog program, it is just a practice to, you just have to draw one block diagram and input and output and its equations. That's a good practice. So we just do that here itself. So half adder, we just imagine just we have one half adder and two inputs A and B, and output sum and the carry. So the sum equation, okay, I think you know about this half adder. The sum equals to AX or I'm just going to represent by this symbol AX or B. And remember, I'm writing all this in a comment. This is not a program, just understanding purpose. Sum and carry equals to A and B, okay, or you can just write AB. This in comment, okay, remember that. AB carry. Now we will go to start our program. So for that, the first word, that's the keyword that we require, is the module. So just module, just type module, 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 and the half adder. So HF half adder, and here we need to declare whatever the ports we need, that is input and the output ports. That means it's just like port means it's just like the external connections, input and the output from our half adder circuit, okay, or our FPGA. Okay, basically it's a FPGA. In that we are going to design our half adder. So for FPGA we are providing the output A and the B, and from this, okay, this FPGA, and from this A and the B, and here is the output. Okay, so half adder and A. Okay, the convention is that it's also a good practice. First write the output, then write the input, so that whenever if anyone read the program, that will easy to understand them. So our output is sum comma carry, and inputs are A and B. Okay, then semicolon, average statement ended with this semicolon, and now we have to specify the output and the input, which are all the output ports and which are all the input ports, because in this single statement it will not going to understand which are all the input and output. So we just write output, which are all my outputs, that is the sum and carry. Okay, then when we come to the input are A and B. Okay, A comma B, these two are the inputs. Now what we have to do, sum, we have the equation sum. In data flow modeling, if we think about the data flow modeling, it's easy to assign any sum to A, X or B, and carry to A and B. So we just have to type assign sum equals to A and A, X or B, then carry. So for that, again assign is a keyword, and carry equals to A and B. I think I'm correct. A and B and X or B. Yeah. For better understanding, you can even write the comments, but for simple these easy statements, I think it's not required. Otherwise, we just write the comment. This is for the assigning the sum, and here assigning carry. Don't confuse about the commenting and the code. The above what we write is a comment, because every statement that started with the double slashes, that's a comment. In Verilog it's a comment. If you are from a VHDL background, then we are using the double slashes in order to double dashes in order to represent the comment. Okay, just don't confuse in between those two. Now I think the program is over. Oh no, I left one statement, that's the end module. That's also important. And end module, okay, module, end module. Yeah, now our whatever the design thing that is going to complete. Now we have to write the test bench for this, because I think we just have to save this. Yeah, it's saved. And where's the run option? Yeah, it is now saved. Here you can see in the profile, you can see this. Okay, just type Ctrl S, it will going to save, and run option is here. if we just run this, I think it will not going to give us anything, because it's some VCS file found em wave, because we ticked the em wave, but there is nothing for that. In order to generate the wayput, we need Testbench. We are testing that, so we have to write that Testbench in order to observe whether our circuit is proper or not. We are only just giving the output in the software, and we are checking whether it is giving the we are giving the input and we are giving the output through the software itself. We are not going to implement this in the hardware. But in the previous, that basic gates and AND gate, we checked how to simulate and as well as the implementation. But here we are just checking through the simulation. Okay, we are not implementing this to that board, because I think implementation is also possible. Here some settings are there that we will see in the later sections. So here for the Testbench, so first the top module, that is module module, I'm going to call this as what's that, yeah, half adder TE Testbench. Okay, TEST, we will just call this as a TB, half adder TB, and nothing is there. There is no any actual ports are required. That is just a software port, it's not actual port. So we just no ports. You can type like this, or you can even just end like this. That's also acceptable. Here I don't know, but in Xilinx, that means ISC simulator tool, that's also acceptable. Here we just write this, and the input and the output. Just remember, IR, input means we have to use the reg. For output, we have to use the wire. In Testbench, all the inputs are represented by the reg and the outputs are by wire. So just type reg and input. Here you can give any name for the input. Here we can see the input is A and B. Here you can give the same name or different name, but it is like whenever we are passing that to this module, that has to be in the same order, like pass by its position. Okay, its position, this position, whatever you are writing first, that will going to assign for the sum. Next one is for carry, next one is for A, and next one is for B, like that. Okay, so here for simplicity purpose, we just use this same thing, sum ABC. Okay, so in that my input is A and B, that only I'm just going to copy. So input means reg, so reg A and B, and the output, that is wire, and here I just have to why I copied this means from this to this means it will not going to confuse. If you use the different variables, that may confuse, so just use the same variable here in Testbench also. Then we have to write our that means we have to instantiate our module which is under our test consideration. So for that, okay, what is the name of this HF? So here we have to write HF, and I'm going to call this as UUT. That means the unit under testing. Okay, for our Testbench, we are writing the Testbench, so just unit under Testbench. You can write anything here, but just simply I'm writing UUT. Then here we have to, okay, not here, yeah, inside this we have to pass the same thing like this, sum, carry, A and B in the same order. Okay, I'm just going to copy this. That's why I use the same variable. We can just simply copy paste from that, so we can save the time. Yeah, now HF, UUT, sum, carry, and A and B. Okay, now we have to write the Testbench for this. So that means some A, B, like what are the inputs, possible inputs. A, B, we are giving only 2 bits are there, so 0 0 0 1 1 0 1 1, 4 possibilities, 2 power 2, that is 4 possibilities are there. So what I'm going to do means A equals to we can give like 1 tick B, that means in binary that is 0. Like this also we can write, that means it will going to represent 1 bit which is in binary, that is 0. Like this also we can write, or when we just think that the binary and decimal, in those both number convention, 1 and 0 remain same. That means 1 in binary is equals to 1 in decimal and 0 in binary is equal to 0 in decimal. So we can directly write 1. That's a simple way. A equals to 1 and another one is b equals to 1. Oh, why I'm writing 1? Because the first is the 0 0. We just start from that. So 0 and b equals to 0. In the waveform, when a equals to 0 and b equals to 0, it has to delay for some time, otherwise we cannot able to differentiate between different state changes. So we have to just write some delay. So #5 represents the like 5 milliseconds delay. Okay, so here we have total runtime is 50. Make sure that this total run, whatever the time we are giving here, sum of all those timings, delay timings, that should be less than this total runtime. So if it is more, then just increase this to more. That's why I told this depends upon our code. Yeah, then we just copy this, then control V, control V, control V, yeah, 4 times. I think okay, that's something I pressed, that's why. Yeah, now I think it's clear. #5 and after this #5, because for the last value also we have to give some 5 seconds delay. I think you've understand this. 0 0 0 1 and 1 0 and 1 1. I think it's visible. If not, I think now it's visible. 1 1. Okay. Yeah. Here to the same thing. Yeah. Now I think it's visible. Both are properly visible. Now after this, what's the next statement? That is the end module. No, I just forgot 2 statements. What's that? That is the initial, begin and the end. If we just write like this, that will just going to parallel process, but if you do the parallelly, you will not come to understand. While drawing any waveform, it has to be for the first it has to be 0 0, then after some time that has to be in sequential. So for sequential, what we have to type means initial. Okay, INITIL, initial, then begin, then here after this end. This we have to write. Okay, then the last thing is the end module. ENDMODULE, end module. Now we may think that we completed our program. Yeah, let's run and we will check whether any error or anything is there. So yeah, it will going to run, but it is giving some error. What's that? Module, end module is missing something. It is giving why. We'll check that. End module. Okay, yeah, this is correct. End module is there. Yeah, the another thing is that we, in order to for the simulation in this EDA Playground, we have to add the 2 extra lines. Okay, in other simulator it is not required. That means in Xilinx ISC tool, there it is not required, but here in order to show the waveform, we have to add another 3 lines that I will give in the description. And okay, you just look at these lines. Okay, this is the dump file. This for the dumping of the wave, so it's only required here. Okay, I'm just going to copy these things and just paste it here after the end. That means before the end module, after your where is that? Yeah, after this, before the end module, this much part you just have to write. Yeah, now we will just control S, just type control S because it has to save, then click run. If any error, then that will going to display here. We will see. Yeah, something error is there. What is that? Home ruler work lab scanning module hierarchy, syntax error, and Testbench SP in line number 17. So here something error we are getting. What is that? Yeah, we missed here the semicolon, because every statement, as I told, it has to end it with semicolon. So here without the semicolon it will going to be the meaningless. #5 end, that is not like that, it's just end. So just type the semicolon here, don't forget that. Now we just save and we'll run it. Okay, yeah, now we got our waveform. Here you can see the A, B, carry and the sum. Okay, this is at how much time we give for each delay, just to tell. That is 10 seconds. That means #5. Oh sorry, that's #5. 5 seconds we give. So this is from 0 to 5. It is a one step change, and 5 to 10 another step, 10 to 15 another step, then 15 to 20 another step. Then this is continued because we gave 50-second runtime. Okay, but this is something like unusual, because here it will changing, but here it is like just straight line. So what we just do means here we just calculate how much time is required. So here it is 5 millisecond, 10, 15 and 20. So 20 millisecond is enough instead of 50, because it consumes some less resources. Okay, so now just type Control S and save it. Yeah, we saved it. Now yeah, it is giving the wave, and here you can see A, B 0 0 and the carry is 0 and sum is 0. And whenever the B becomes 1, that means B is our LSB and A is our MSB, AB, like that. So 0 1 0 1, when we add 0 and 1, we are going to get the sum as 1. That's why the sum is 1 here. We can even get the values like by clicking like this, I think. Yeah, here you can get even the time you can get, and here there are some options. We will just see that one by one. What is it? Get signal? No, I don't know this. Plus this is for zooming, zoom out and zoom in, and I think yeah, this is the time. Yeah, that's it. If you want, you can just take the screenshot of this waveform, or else this code will be saved. If we just save, I think you have understand about this. Now the main thing that you have to remember is that here you have to give LDIC Revera Pro. Okay, this one, that's I checked. So and here just click on this. Okay, that's it. And if I go to my profile, yeah, I think I have saved this. Yeah, I saved, and we can, I think we can even rename that. I'm searching for that. Just go to profile. No, just go to playground. Your playground. That means whatever the my codings are there, that will going to show here. You can see no name UDJS. This is my code that I wrote now. This one, where I have to change the its name. I think no. Add a title to help your playground. Okay, yeah, here we have to add one title. I'm going to call this as half header, and a short description. Half header, yeah, this only we can just copy and paste here, a short description. Okay, then it's a public, everyone can view, or private, or will appear in search results. Anything you can just I'm just making this as a public so I can share here. So just click save. Then I think now if we share this link, I'm just going to open this in another incognito mode. Then I think the others can view this. yeah, this again in my account. Yeah, now I'm completely log out of my account, and whenever if you use this link, it will going to use that program. Then you can add it, or I'm going to share this link. You can add it to this and you can just type run and check for the graph. You just make your account and starts from the beginning. This just for the reference. I think you understand this. Thank you.